Angular momentum and its conservation 3. A puck attached to a string passes through a hole at the center of a frictionless table. Initially, the string is held lightly, and the puck travels in a large circle. Then, the person pulls down harder, moving the rope down. When the person pulls harder, does this exert a torque on the puck? No, it does not. Any force with a line of action through the center of mass of an object exerts no torque on it. So there is no torque exerted on the puck. How about question 2 here? Will the rotational inertia, or the moment of inertia, those are synonyms, angular velocity and/or kinetic energy of the puck change? What's going to happen to the moment of inertia when we pull down the mass of the puck? It's going to be closer to the rotational axis, and we know that the moment of inertia is related to how far away mass is from the rotational axis. And if the mass is closer, then that means that the moment of inertia is going to decrease. What about the angular velocity? Well, if there's no net torque on this system, then angular momentum is conserved, which means that initial angular momentum is going to equal final angular momentum. And one equation for angular momentum is I times omega. The I we just found got smaller. So the moment of inertia initially was bigger. And what does that mean for omega? This one has to be smaller and this one has to be bigger. So omega is going to increase. What about kinetic energy? Kinetic energy of rotation, you might recall, is 1/2 I omega squared. And at first you might think, well, it'll probably stay the same because I gets smaller and omega gets bigger. But look, omega is squared, isn't it, in this equation? And so, yeah, there might be a canceling effect for one of these, for this I and maybe one of these omegas, but there's a factor that's squared for omega. So that must mean that the rotational kinetic energy, like omega, is also going to increase. Is work done by the person on the puck? Remember that the person pulls down on the rope so that the puck has a smaller radius. Does that person do work? We said just a second ago that there was no net torque, but is the person doing work? Yes, the person does work. We just mentioned, it's boxed in on the right side of the screen, that the rotational kinetic energy goes up, and by the work energy theorem, if we have more kinetic energy than we did before, then we must have done some net work. So yes, this person did do work on the puck.